Okay, so question number 21 from from May, June 2016, paper 2, variant 2. Question on angles and circles. We're told in this diagram, the circle here, A, B, and C are on the circumference of the circle, and we're told that O is the center of the circle. We see there's an angle formed there. We're also told that there's an angle here which is 28 degrees. And we're asked to work out the size of angle ACB, and it says give a reason for each step in your working. Give a reason for each step in your working. So it's very important that we do that. Okay? We need to give a reason for each step in the working here. Okay? So now, when you have a question on angles in circles, all right, one of the things that is very important for you to do is to try to see what type of information you can gather from the question straight away. Now, one of the things we see is OA and OB are both the same length because they are both the radius of the circle. OA is the radius and OB is the radius. So one of the things I would do is mark on OA and OB the actual length of the line. Okay, excuse the bell. That's OA and OB. Okay, those are the same length. Those are both the radius of the circle. That makes this triangle an isosceles triangle. Okay, so I can say this angle OAB is also equal to 28. Now this question says give a reason for each step in your working. So for that reason in this question, I have to give a reason. I can't just write this down. If it didn't say that, normally, with questions that we're normally used to, okay, it wasn't really necessary in the past to give a reason. That would have been enough. But they've mentioned here, give a reason for each step in your working. So what I can say is the angle OAB is equal to the angle OBA, which is equal to 28. And the reason is I can mention because they're isosceles triangles. Now don't worry if you don't know how to spell isosceles correctly, because even I'm not very good at that. Okay, so isosceles triangles. Okay, they are both it's basically an isosceles triangle, so those are going to be equal angles. That's enough for you to get the answer. Now the next thing I can say is I can find out what angle AOB is because it's in the same triangle. Okay, so I can say AOB is equal to 180 minus 28 times 2. There's two 28s there. These are three angles in a triangle, so this angle is going to be 180 minus the sum of those two. Okay, that gives you 180 minus 56. Okay, 180 minus 56, which is going to be 124. 180 minus 56, which gives you 124. Okay, that's 124 degrees. All right, so I know that that's 124 degrees. Now we're getting somewhere. Now I can work out what the angle is that I need here, which is ACB. Now ACB, I know, is related to AOB. They both are standing on the same arc. They're both subtended from the same 2 points on the circumference A and B. AOB is formed at the center. ACB is formed at the circumference. The angle at the center is always twice the angle at the circumference. Okay, if they're coming from the same arc. So I can say that the angle ACB is equal to a half of 124. So angle ACB is equal to a half times 124, which gives you 62 degrees. Okay, now for this reason I would put here, for the reason before, angles in a triangle. That's fine. And for the second one I will say that you can say angle at the center is 2 times angle at the circumference. These are perfectly fine reasons for you to give for the answer. Okay, so our final answer is going to be 62 degrees. 62 degrees. And there we have it. That's how you answer such a question.